Hello, future engineers and physics enthusiasts. Have you ever wondered how massive skyscrapers stand tall against strong winds? Or how a simple bridge can support the weight of countless cars? The secret lies in a fundamental concept: force systems. Today, we're diving deep into this fascinating topic to understand how forces shape our world and how we can master them. So, what exactly is a force system? Simply put, it's a collection of forces acting on an object. Imagine pushing a box. That's one force. Now imagine your friend is pulling it from the other side. Suddenly you have a force system. These forces can push, pull, twist, or bend, and understanding how they interact is the key to everything from designing a stable chair to launching a rocket into space. The real magic happens when we talk about equilibrium. An object is in equilibrium when all the forces acting on it are perfectly balanced. The net force is zero, which means the object is either stationary or moving at a constant velocity. This is the ultimate goal for any structural engineer. Think about that towering skyscraper again. Gravity is pulling it down, the wind is pushing it sideways, but the building's internal structure creates opposing forces to keep everything perfectly balanced and stable. That's equilibrium in action. Let's break it down further. Forces have both magnitude, how strong they are, and direction. To analyze a force system, we often use a technique called vector resolution. We break down each force into its horizontal X and vertical Y components. It might sound a bit like math class, but it's a powerful tool. By adding up all the horizontal components and all the vertical components separately, we can determine the overall effect of all the forces combined. If both sums equal zero, congratulations, your system is in equilibrium. This principle is what ensures a bridge doesn't collapse and an airplane wing generates enough lift to fly. But what if the forces aren't balanced? That's when things get interesting. An unbalanced force system results in acceleration. Just as Newton's second law tells us, force equals mass times acceleration, F equals ma. This is the principle behind motion. When you kick a soccer ball, you're applying an unbalanced force, causing it to accelerate across the field. When a car's engine provides more force than the resistance from friction and air, the car speeds up. Understanding this dynamic side of force systems allows us to predict and control motion, which is crucial for designing vehicles, machinery, and countless other technologies that define our modern world. From the grandest structures to the simplest movements, force systems are the invisible architects of our physical reality. By learning to analyze and balance these forces, you're not just solving a physics problem, you're gaining the skills to build, create, and innovate. You're learning the language of the universe. I hope this has given you a clearer picture of the power and importance of force systems. If you found this helpful, please give this video a thumbs up, and don't forget to subscribe for more deep dives into the amazing world of engineering and physics. Thanks for watching, and see you in the next one.